Now that we've already worked with rational expressions that have like denominators, adding and subtracting them, we're going to work with ones that have unlike denominators. So to start off with, I'm just going to kind of refresh your memory. What would happen if I have, for instance, 2/3 plus 1/4? Okay, so if I wanted to add these, I would have to have the same denominator. So by doing so, I'm going to multiply this 2/3 as 4/4, and I multiply the 1/4 by 3/3. Now, how did I know to do that? I took 3 here and moved it over, multiplied it by the other fraction. I took the 4 that was in my denominator of my other fraction and multiplied it on the other side. So then I would have 8/12 plus 3/12, and then I could add those two fractions together. Okay, so when we have rational expressions, it's the same type of concept. Okay, for example, if I had x over 2 plus 3x/5. Okay, so I'm going to do the same thing that I did before. I have a 2 in the denominator here, so I'm going to multiply the other fraction by 2/2. Since I have a 5 in this denominator, I'm going to multiply this side by 5/5. Now I'm going to rework this. So I have 5x over 10 plus 6x/10. I now can add those because they have like denominators. So I have 11x over 10 as my final answer. Now what happens if the denominator is a polynomial? So let's say that I have 7/3x plus 15 plus 4/x+5. Now in this case, my steps are a little bit different. The reason being is I'm going to factor that 3x plus 15. My goal is to always factor out the GCF right away, just like when we were multiplying and dividing rational expressions. So right now I have 7/3 times x plus 5 plus 4/x+5. Now this makes it a little bit easier in the sense that I'm going to multiply by that 3x+5. By multiply, I mean I want to get that 3x+5. So in this case, because I already have an x plus 5x+5, I need that 3. So I'm only going to move it over to this side. I don't have to do anything to the other side. So now I have 7/3x+5 plus 12/3x+5, which then gives me 19/3x+5. So let's do one more of these. Let's say that I have 7 over 3x squared plus x plus 3 over 6x plus 2. Before you do this on your own, my hint is to factor out the GCF of both denominators. So I'm going to go ahead and factor out my GCF of both to see what I'm left with and what I really need to multiply. That's the reason why I'm doing this. So when I see here that I have an x here and a 2, I know that I'm going to have to multiply the first one by 2 over 2 and the second one by x over x. So I'm left with 14 over 2x times 3x plus 1 plus 3x over 2x, 3x plus 1. Well, now I can go ahead and add these. Notice though that the top, the numerator, they're not like terms, so I can't actually truly combine them. So I'm left with 3x plus 14 all over 2x times 3x plus 1. Something to note, if for instance that I could simplify or cancel out something from the numerator and denominator, you need to go ahead and do that. Now, let's work with something where we have a polynomial that's not the same. So for this, I've got x minus 5 over x plus 1 minus x plus 3 over x minus 1. It's the same concept. I'm going to multiply by the denominator to both sides. So on this side, on the left here, I'm going to multiply by x minus 1 over x minus 1. On the right, I'm going to multiply by x plus 1 over x plus 1. So I'm left with x minus 1 times x minus 5 all over x minus 1, x plus 1. So notice here, you can see that I've got that x minus 1, and you don't want to cancel it yet. Don't do that yet. Minus x plus 3, x plus 1, all over x minus 1, x plus 1. Okay, here's why I'm saying don't cancel them out yet. I mean, the whole point was so that we had that. We knew we were multiplying by that anyway, so that it was going to cancel. So I'm left with right now x minus 1 over x minus 1, x minus 5, minus x plus 3, x plus 1, all over x minus 1 times x plus 1. Now, you're not done. I know you think you probably should be, but you aren't. The reason why is because when we were going with the like denominators, we combined our like terms. So remember, if I had, for instance, 2x over 3 minus 5x over 3, I combine my like terms, so I would have negative 3x over 3. Well, I don't necessarily see that right now because you need to distribute. Okay, so what you're going to do here is you're going to distribute this top part. Not the bottom part, just the top part. So looking at this, I have x squared minus 5x minus 1x plus 5 minus x squared plus 1x plus 3x plus 3 in that top part. And that's all over x minus 1, x plus 1. Okay, so now at this step, you're going to combine like terms. So I have x squared minus x squared. I don't have an x squared now. Technically in the green here, I've got minus 6x minus 4x. So negative 6x minus 4x gives me negative 10x. Then I have 5 minus 3, which gives me 2, all over x minus 1 times x plus 1. I'm going to factor the top. In case something would cancel. I can factor out that 2, and I do not have anything that cancels. This right here is my final answer. I know this takes a while. Okay, you won't have very many that are like this, but you need to know how to do this.